everyone. My name is Aaron Cohen. I'm here from Avantgarde Finance. We are the lead maintainers of Enzyme Finance, which, as you know, is a decentralized asset management protocol infrastructure built on Ethereum. What does this actually mean in practice? Using Enzyme smart contracts, you can start a vault. You can allow investors to buy shares in that vault. Then you can take the money that they gave you for those shares and allocate them across various decentralized protocols. So you can lend, farm, pool, swap, kind of the world is your oyster, whatever you like. Based on how well you do that, you can earn fees for yourself and for the fund. So that's sort of the high level, and I'm sure what Marina said last Thursday when you spoke to her. I'm here to talk a little bit more in detail about what goes on under the hood and how you can control the functions of an Enzyme Vault programmatically. So in order to do that, I built this cool little diagram. To start here, we need a basic understanding of smart contracts and Ethereum accounts, and this is super high level. I'm sure sort of remedial for some of you, but I think worthwhile anyway. Sorry, can somebody mute? I keep getting notifications, or maybe that's me. A smart contract is a small program that's running on Ethereum, which acts deterministically. So given an input, you'll always be able to predict the output of that program with 100% accuracy. An account is how a user interacts with these programs, most often by sending value back and forth between them, but sometimes querying data, triggering events, etc. Enzyme Vault, the thing I just described, is essentially two contracts that coordinate with one another. So it's got the vault contract. This is where it holds assets. It's where investors buy and redeem shares from. So it's got this share issuance logic. And then the controller, which is sort of the brains of the operation. It is permissioned to spend vault assets in specific ways, and it interacts with external protocols. So it's sort of the portal between the Enzyme Vault and every external protocol out there. As a vault manager, you're permissioned to call functions on both of these contracts. Extensions and adapters are a class of infrastructure contracts that are shared by all vaults. So anybody who creates a vault gets to access to these contracts. We'll go into the next slide. Extensions are modular contracts that enable vault configuration and interaction with the outside world. So you can see there are three extensions currently: the fee manager, the policy manager, and the integration manager. The fee manager and the policy manager are both sort of enabling vault configuration. When you create a vault, you're storing settings specific to your vault on a mapping on an external contract. If your comptroller ever needs to know those settings, like if you wanted to claim fees, it queries the fee manager, then queries the performance fee contract, which checks its internal mapping and sends your fee settings back to the comptroller, which then uses those fee settings to calculate how many shares to issue to you in the form of fees. So policies work very similar. Risk management policies are checked before any trade or sort of transfer of assets is done, and compliance policies are checked before any investment or redemption activity occurs. Those are sort of the boring parts. We're going to spend the rest of today talking about the integration manager, and I've got probably 10 to 12 minutes on this, and then we can maybe dive into questions if anybody has them. So the integration manager, let's say a manager has USDC sitting in their vault, and they want to lend it out on Compound to earn some interest. First, the manager has to decide how much USDC to lend out. So you're in the app, you say, I've got 10,000 USDC, I want to send 5,000 of it to earn less than 4% on Compound. How does that actually happen? First, the comptroller calls the integration manager, which calls the Compound adapter, which executes the transaction within the Compound protocol contracts. So it's a coordination between a bunch of different contracts, but the end result is that USDC leaves the vault contract, and is replaced by CUSDC, which is Compound's tokenized representation of your lending position, which is cool. This all happens permissionlessly. It's all decentralized. That's awesome. But we're relying on the manager to do two things. First, deciding how much USDC to lend, and actually clicking the button to execute. So we could do those things programmatically, no longer need humans. Turns out we can. Enzyme SDK supports every contract on the Enzyme protocol in the form of a JavaScript class. So this means that every infrastructure contract, a Vault specific contract is available despite the fact that it was written in Solidity and compiled into bytecode and deployed onto Ethereum. You import the library, you import a specific class, and then you have all of that functionality available to you in native JavaScript. The SDK wraps around Ethers, which is a well-known library for Ethereum-specific transaction logic. Sorry, I had a little workflow issue there. The basic workflow is simple. You import the library. You also import Ethers. It's a necessary dependency. Then in the file where you're working, you import the appropriate contract classes. So this would probably entail sort of looking at the diagram or the protocol specs and figuring out what contracts you need. Then you instantiate that class using the correct address where the contract sits on the Ethereum blockchain. And these Ethereum-specific details, we'll get into that in a second. Then you pull together various function parameters. So in the Compound example, it's basically just how many USDC to lend. And you pass that to the appropriate method, then call the method and execute. So we're going to take a look at what that actually means in the code. This is an example of a trade on Uniswap. This example sits in the SDK docs, so you guys can reference it afterwards. But I'll walk through it here step by step. The first thing I'm doing is importing all the stuff that I need from the SDK. These are a bunch of helper functions and an enum, and this is the actual comptroller contract, which is what we'll use to execute the transaction. I'll kind of reference back to these as we get to them in the code. So next, I'm getting my Ethereum-specific details in order. The provider is sort of what you need to know in terms of how you're connecting to Ethereum. This is like, infura.com/whatever. And ETH network is mainnet or Kovan. The signer is an Ethers-specific object that represents an Ethereum account. In this case, the wallet is a concrete subclass of signer, which allows you to sign transactions on behalf of that account. So I'm intentionally glossing over where to store your private key because that's sort of outside of the scope of this conversation. You can see in the bot repo that I think has been posted that I used an environment variable. I think there are probably a million ways to do this, but this is a sensitive piece of information that you certainly don't want in a public repo. Keep that safe. So next thing I'm doing is creating variables that represent all of the addresses that I'll need. So for Vault specific stuff, like the comptroller address, this is available on your Vault's page on the Enzyme app. If you scroll down to the bottom, you can see sort of the list of contracts here. For the infrastructure stuff, this is like publicly available contracts. Those are available at contracts.enzyme.finance. This redirects to this helpful Google Sheet, which has every deployment of the protocol and every contract on those deployments, address and Etherscan link. So here I've got the Uniswap adapter's address, the integration manager's address, and my comptroller address. These are all obviously fake. So now the exciting stuff. Think about what we're actually doing here. We want to, let's say we want to sell USDC, say we've got USDC in our vault, we want to sell USDC for MLN. We are calling a function on the Uniswap smart contract in order to do that. In order to know what to do, that contract, in order to call that function, we need to know what arguments it needs and format them in a way that it's going to understand. So that's where these helper functions that I mentioned above come in. And the way I like to think about this flow is assemble the sort of outermost stuff first, then the next level in, then you actually call the contract. So in order to assemble the Uniswap arguments, we will use the Uniswap v2 take order args helper function. And there's a list of all the helper functions in this SDK documentation. For this one, we're passing it some Uniswap specific information. Path is, so Uniswap, if we were to trade from USDC to Melon, would probably go USDC to WETH to Melon. The path would then be USDC, WETH, Melon. The minimum incoming asset amount is how much Melon you expect to get in return for your USDC. And the outgoing asset amount is how much USDC you want to trade. So just in the context of this specific example, these two arguments, you probably have to get from the Uniswap SDK. And there's an example of how to do that in the bot repo. So we pass this function all of these arguments, it spits out some bytecode. So now we have the correct arguments for this part of the transaction. Moving backwards, the integration manager is how the controller, how your vault knows how to interact with these contracts. So it needs some specific information as well. It needs to know the details about the functions you want to call, in this case, on the Uniswap adapter. So we'll use another helper function, this one call on integration arguments, args. I'm going to pass it three things. One is the adapter. So this is the Uniswap address that we got from the spreadsheet here. The next is the selector. So this is a constant that's imported from the protocol or the SDK as well. There is a list of these in the SDK documentation too. They're very easily named. So, like for example, we want to execute a Uniswap take order. This is the take order selector. And then we pass the arguments that we assembled here for Uniswap. So basically we're saying which adapter is being called, which function is being called on that adapter, and which arguments we're passing to the function on that adapter. So third and final step, which is where we actually execute the transaction, we will instantiate, well, we've imported this comptroller lib class from the SDK, and we'll instantiate a new instantiation of it, passing it our specific comptroller address, as well as the signer object, which is associated with the Vault Manager. So this is important because this class now has permission to, execute transactions on this, execute functions, call functions on this contract, which we'll do here. And the syntax here is a little bit funky, but basically we're telling the comptroller to call on an extension, and we're passing it these arguments. The first is the integration manager's address. So this is the address of the extension for the comptroller to call on. Then an enum describing the function that it's calling on the integration manager. So again, this is imported from the protocol as well. And in almost every case where you're making, in fact, in every case where you're making a trade using an external protocol, you will use integration manager action ID dot call on integration. So you pass it. So we've passed it which contract to call on, the function to call on that contract, and then we pass it the sort of assembled bytecode that we've gotten together up here, which is sort of the sum of the specific arguments for Uniswap, then for the Uniswap or for the integration manager, etc. So I know that's a lot, but the way you can think of the flow is essentially from the most sort of external protocol specific here to the going back to the vault. So it needs to know the order specific stuff, and then the contract specific stuff, and then the infrastructure specific stuff here. Calling this function results in an Ethereum transaction object. You're not done yet. So this is an object that requires you to hit the send button, essentially. Once you do that, it's sent to the mempool, and if you await it, you'll get the receipt. So once it's done, once it's been mined, you'll have the hash, the block number, and a bunch of other stuff that you can find in the Ethers documentation. So that's basically it. That is, I thought, useful to know in terms of how the coordination works between the comptroller and these external protocols. It will be very similar for Compound, you know, every external, I'm blank, Aave, all the other stuff that we interact with will use this pattern of preparing trade-specific arguments, then adapter-specific arguments, and then passing those to the call on extension function on the comptroller. So I think with that might be a good time for some questions. And if there are any, maybe we can go into the event chat and do it there. Or unmute yourself. I'm happy to talk in real life as well, whatever you guys are into.
What has anyone? I know this is a very new SDK, but like, what?
You cut out there, but I think you're asking what people built with this, right?
What feedback have you been getting from people developing on this that like they've either been struggling with or hasn't been so? It's not too old, but like, yeah, I just want to know like common like mistakes people run into working with this.
I mean, I think, well, so it is fairly new, and the documentation got released last week. We, I think, had one comment in our Discord about the documentation, which was pointing out a typo. So we haven't had a ton of really substantive feedback in terms of what people are having trouble with. I know what I think I would have trouble with, and having written the documentation and the whole front end of the application on this SDK, it's very low level, which means that it's infinitely configurable, but it's not, it's occasionally not super straightforward. So this flow that I showed of having to call on extension, you know, prep all of these arguments in order, or the order doesn't matter, but prep all of these arguments, well, I guess it does actually. Prep all of these arguments in order and then pass them to the comptroller. That's kind of a pain. And I think our goal, you know, and probably, I don't want to say a time frame, but eventually we will release a higher level where you can just say a higher level SDK where you can just call a trade on Uniswap function and it'll do all this stuff underneath the hood. But in terms of like actual substantive feedback, we've not really gotten a ton of it yet. So interested to hear when you guys start building on it.
Oh, and another thing I want to know is like, so how would you begin to build like a front end that simplifies these arguments, or for people looking at it not on the contract level? Have you guys explored like building an enzyme application? Is that, but like how would you suggest starting to work with this protocol and then building a front end that allows?
Well, so I think it depends on what you want the front end to do. So I think that this SDK is good for actually executing Ethereum transactions. What it's not good for is sort of fetching historical data and showing what your fund has done in the past. That I would use our subgraph, which is very expansive and has an indexed record of every transaction that a fund's ever built. So from a visualization, or every transaction that a fund's ever executed. So from a visual perspective, like that might be more interesting than what the protocol can provide in a lot of cases. However, if you want to do active management of the protocol, then you will need to use the Enzyme SDK, or active management of the vault, then you will need to use the Enzyme SDK. So I guess the way I would go about building a front end is figuring out what like your goal was, and if it's to interact with the contracts and actually execute transactions and trades and stuff, I would start by just building a bot and not worrying about the visualization at first, because it's fairly easy just to throw together a JS app or something like that you can build a trade button on. But figuring out the actual mechanics of it are a little more challenging. So I would look at first how to maybe even just looking at the Enzyme bot repo that I built would give you an idea of how to like call a function and have it actually work. And you could sort of move from there into the orchestration of a bunch of different functions and then build the front end on top of it. But in my opinion, if I were going to use the SDK for executing transactions, I would do it programmatically at first. So I got a hang of it. Then I would move to the front end stuff.
How many extensions are like there, like other than Uniswap and Compound? I know it's in the documentation, but it wasn't in that visualization. Just want to get a sense of like what is right now for the Enzyme SDK.
User docs. I think that's in the user docs. Yeah, it's on the. These are the current integrations that we have. And on the front end, we've sort of abstracted a lot of these trading protocols away so that you just see one interface. And I don't have a fund open at the moment, but so this is everything that we're integrated with at the moment. Yearn is coming this week. I think Aave borrowing is happening in the next couple of months. Balancer in the next couple of months. That's it off the top of my head. But we're sort of continually integrating new extensions as there is demand.
What's like the timeline for like when you integrate and then when the SDK will be updated in terms of and with the documentation? Is it like same time or is there a delay?
That's me, kind of. So hopefully instantly. The SDK will be updated. So the SDK is largely generated from the protocol contracts. So as soon as there's a new integration that is released to mainnet, the SDK will have class representations of that integration's contracts. And in many cases, like Yearn, for example, I don't think I'll update the documentation because it's going to be the same as the flow I just showed you, which is get the Yearn address, get the correct Yearn helper here, and then all of this stuff is going to be the same. So for that kind of thing, I don't know that this documentation will be updated very frequently. I think where it will be updated is if there are, changes to this flow, or if we eventually build a higher level library. So I think this will always be available, the JavaScript TypeScript class representations. But I do think there will be a higher level where you can just import a function that says trade on Uniswap or trade on Curve or that sort of thing. And in that case, the documentation will be updated as soon as it's available.
Are there any trade-offs with directly interacting with the protocol versus like the SDK? Or is there a reason for directly calling the contracts over the SDK?
Well, if you don't know Solidity, it's hard to call the contracts. Or do you mean on Etherscan or?
I mean, say you know Solidity, or maybe you're looking from a high frequency perspective. Is it faster to call the contracts than working with the SDK, or is it what are the?
I actually don't know that from a high frequency perspective. I think if we put that aside, I think that probably it's what you're comfortable with. For me, I have a very not even junior. I barely can read Solidity, right? So I don't know it, but I can read and write TypeScript pretty well. So this is just an easier dev environment for me. I think if you know Solidity and you're comfortable inside the Solidity development environment, then you're absolutely able to interact with it that way. And it's probably, it just ends up being what you're more comfortable with.
Hey, Code. You guys hear me?
Okay.
I just want to say, I know I've been following this thing since about March, April timeframe. I do like the new website for the protocol, better than previously. I think it does a lot better job at explaining the protocol and being able to follow the steps to install the protocol step by step. And also the SDK, the bot SDK, it's a huge improvement in the past couple of months. So I do appreciate it. I would like to see. I know it's difficult to create something on the testnet, because I think when we go to test this thing, other developers, the Kovan network seems to be down right now. But when it comes back, I mean, we do testing on the Kovan, and so starting a vault on the Kovan net, and getting the wrapped ETH or the enzyme. I kind of have to piece it together. So that was a little bit challenging. So maybe having a step-by-step guide on how to do that, that would be helpful in the future.
Yeah, that makes sense. So our Kovan deployment, all of the tokens, wrapped ETH, etc. No, sorry, wrapped ETH is the Kovan wrapped ETH, but the other tokens are specific to our deployment. So that's a good point that we should build a faucet for that if it's possible. Did you say Kovan's down currently? What do you mean by that?
Yeah, the Kovan ETH is down, so you can't get Kovan ETH, and then your wrapped ETH for Enzyme is a special contract, so it has to be. You can't just go to Uniswap and get wrapped ETH because it won't work.
Okay.
So there's a site, and I know the process to do it now for Enzyme, but it's not written anywhere. So if anybody else wants to do it, they really have to know the process. Otherwise, it's not going to work.
Where do you get the right wrapped ETH right now if you're doing a network on Kovan?
You have to know the link. There's a link for the Enzyme wrap ETH, and there's a process. You have to write the contract. I did it on the video. I did it on one video, one of those 3 videos that I did. But I do need to make a shorter video on how to do it.
We can. Did you do it on Etherscan?
I did it on the. Oh, I have to pull it up. Yeah, I will have to pull it up. But there is a website to go get the wrap ETH. For the enzyme. I'll pull it up while you keep on doing this.
Yeah, so I think we've got a list of, that's a good point. That's a good resource that I should put on the SDK for testing. We have a bunch of Kovan specific or enzyme specific Kovan assets that you can go onto the scan page for those tokens and call the mint the mint function and just pass it your Kovan address or your ETH address. So I can add that as a walkthrough, maybe on one of the
and I have it also.
building block things over here.
I have it on my YouTube channel also. But how do we get? Okay, so is there a way to get? I don't know if there would be a way to get some wrapped Kovan from Enzyme instead of having to go to the Kovan faucet to get, because the Kovan faucet is down. It's absolutely down. You can't get any Kovan ETH right now.
I don't think that's gonna be like a persistent problem for too long. There's no like.
It's been down for almost 3 weeks right now.
What?
Yeah, it's been down for almost 3 weeks. If it wasn't because, remember, I was collecting wrap ETH for like the past 3 months. It's been down for almost 3 weeks. It's crazy. And then if you go to the alternate site, they're not responding because I went to the alternate site. And people are pissed.
Yeah. All right. I think there's probably limited things we can do about the actual Kovan ETH, but we can probably figure out Enzyme Kovan WEF. So yeah, I'll work on that. I'll let you guys know.
Yeah, it was because it was. I remember it was hard to like to put it in whatever coin that you wanted. You needed like I think Wes was the only one we could get. Another person was trying to do that in the last presentation to start a fund. But I thought he got the wrapped ETH. But yeah, it was. I mean, Jose, can you like get other? You can't get anything other than wrapped ETH to start a fund with right now. Like even if you had the
you gotta have the right wrap ETH. Where's the chat for this thing?
you should put in that
Event chat. I got it. Yeah. Let me put the link for the Kovan Ether scan for the wrap Ether for Enzyme. That's where you would go.